All right, in the previous segment we had gotten as far as saying that more mass means more weight, which means more centering force. More centering force means it's pulled to the center harder, which means that it should take less time to get to the center. And if it takes less time to get to the center, that means a lower period. Now, we have two different chains of logic here. And that's probably a good thing because we want to be able to show that mass has no effect on the pendulum, period. And in fact, we can do that by seeing that this influence, more mass, more inertia, longer period, is counterbalanced or counteracted by more mass means more weight, which is more centering force, which is less period. So more mass, more period, but the other effect that's going on is more mass is less period. Both of those effects are going on at the exact same time as the pendulum swings and as we change the amount of mass. Both effects are going on, and those two effects tend to cancel each other out. So we could say, therefore, an increase in mass has no effect on period because the two effects of inertia and centering force cancel each other out. Now, let's try to put that into a paragraph form. Okay, so here is a paragraph that describes or gives that same explanation that we wrote in shorthand here. You can go ahead and pause the video and give that a read if you'd like. And then we're going to go on and do one more example of an explanation. All right, so our next one is actually a prediction. Of course, good scientific models not only make good explanations, but they ought to make good predictions also. So let's make a prediction. How will an increase in the gravity rating affect the period of the inertia balance? Just a quick refresher. Gravity rating is a measure of the size of the planet that the experiment is being carried out on. Different planets have different gravity ratings, and different gravity ratings affect the weight of an object on that planet. So let's take a look at our chart, and let's see about what kind of effect we're going to expect here. So we notice that the gravity rating of the planet will influence the weight of the object, or in this case, the weight of whatever's on the inertia balance. Now, that weight should affect the centering force, and the centering force should affect the period. But we better check to see what the centering force on the inertia balance is. We know that notice that the inertia balance has a centering force, there it is right there, of springs, the side pieces on the inertia balance. There's the inertia balance. These side pieces are kind of springy. They're the things that pull the inertia balance back to the center of its oscillation. So in fact, weight is not a centering force of the inertia balance. And therefore, even though the gravity rating will change the weight of whatever on there, it won't change the centering force of the inertia balance because weight is not the centering force. Therefore, from looking at this chart, changing the gravity rating, while it will affect the weight, will have no effect on the centering force and therefore no effect on the period. Let me write that out for you. Okay, so a increase in gravity rating means an increase in weight, but no increase in centering force because weight is not the centering force for an inertia balance. Therefore, increase in the gravity rating will have no effect on the period. And you can imagine writing that out completely in words. Anyway, hopefully, coming back to our main focus here, you're able to write a good scientific explanation now.